Um, Good morning to everyone who's joining us today. Welcome to day two of the big data conference, which is being hosted by Data Science Zimbabwe. We're looking forward to having great sessions today, focusing mainly on applications of artificial intelligence, of data science, of deep learning to various use cases. For our second presentation, we've got Tinevimbo Musingadi, who's a high school AI enthusiast who has been working with deep learning models for his projects. So he will take us through some of the work that he has been doing and some of the things that he has been investigating and exploring. And we hope that we will learn from his passion for this particular field. Right, Tinevimbo, you can take it away.
Okay, so thank you, sir. So greetings to everybody tuning in. My name is Tinevimbo Musingadi, and yeah, I am a high school student at Maboko High School. But most importantly, I am a researcher. I'm an AI enthusiast. I love working on solving different problems. And then enter science phase. I'm sort of like well versed in the scientific domain. But yeah, to me, artificial intelligence and big data is like this powerful tool that can be used to solve almost any problem. That's why my topic for today that I'll be sharing is solving real world problems using deep learning. Um, so uh, this basically the insights of this, of my presentation is based on one. I'll take you a crash course through deep learning. I'll just for those for background purposes, I'll just explain some deep learning algorithms, and then we will tackle the importance of algorithmic fairness. And when you're stepping from academia and you're now trying to solve real world problems, right? These are the factors that you should consider, because in real world data is not going to be evenly distributed. Some algorithms will be biased, and this issue has to be addressed in order to ensure that your solution uh, is fair to everyone who's going to be using your product, whether it's a product or whether it's in the scientific domain or whether it's in medicine or agriculture. So a little bit of background about myself. I am a student researcher. I call myself an inventor, and so far I'm currently working on three major projects that involve artificial intelligence, but specifically deep learning. The first one is the last minute flood warning gadget, and I was motivated by Cyclone Idai, and it's a gadget that uses AI to predict floods, flash floods. Yeah, and I'm still working on the problem. So working on it, it is sort of gave me exposure, because I'm working with degenerative models, trying to see if I can recreate weather patterns in future, and then try to predict if there'll be large rainfall. And yeah, also I'm working on other. So as you can see in the slides, this is the last minute flood warning gadget, and yeah, it uses artificial intelligence. It detects clouds, it combines it with temperature data, and yeah, it's based on deep learning models. And also, um okay, so these slides are a bit weird, but to those who do chemistry, there are these files which are known as these molecules that are known as metal organic frameworks. So what I'm trying to do is that I'm trying to use a neural network to predict a certain catalyst that can be used to filter air and filter for carbon capture. And yeah, working with those with working on this problem, I'm actually venturing in reinforcement learning, because there isn't enough data, clearly labeled data in terms on the chemistry side of things, right? Next slide. So yeah, there are plenty of applications. I think from from when we started, this conference, right? There were people in agriculture, GIS, e-commerce, robotics, healthcare, and weather forecasting, right? So deep learning is a tool that can be applied in almost every sector. But now, what's important is actually understanding each and every individual algorithm so that you may be able to apply it in your certain field, right? So this is the purpose of my presentation. But deep learning is a huge field. But I'll just try to do a crash course that I'll just try to explain the fundamentals. So in our respected fields, right, there are plenty of problems. Like in agriculture, there are still problems that we still have to tackle. I was actually amazed by Mr. Lovemore's. I was actually, yeah, inspired and by Mr. Lovemore's presentation on agriculture. And yeah, there are still plenty of problems, particularly in Zimbabwe. And this is when deep learning will come in handy, as well as medicine, manufacturing, and all sectors of the economy, right? E-commerce, production of chatbots, managing resources, and deep learning, I think, can be used in those sectors and play a critical role in actually solving the individual problems that we face in our respected fields, whether it's the commercial industry. Um, let's say maybe you're trying to detect fraud before it happens, or you're trying to automate a certainly huge task, right? So these algorithms will be essential in our fields. So yeah, uh, so how does deep learning actually help in solving real world problems, right? So deep learning is a subset of machine learning and artificial intelligence, right? Deep learning is when you are sort of like deriving those algorithms from scratch rather than in machine learning. Yes, you use already made algorithms, right? You use your convolutional neural networks. And machine learning critical, it sort of like tries to uh make sure that the data is well sorted for a certain algorithm. Whereas in deep learning, you have the comfort of saying, okay, if I combine a convolutional neural network and a degenerative model, which problem may I be able to solve? So deep learning is critical for solving real world problems, as well as data addressing data bias and algorithmic fairness. Why? Deep learning thrives on big data, right? The larger your data set, the more the higher probability of actually solving a certain problem. So uh, if your data is a bit biased on a certain maybe certain characteristic, then you will be it will result in what we call algorithmic unfairness, right? So let's jump into the next slide. Let me So I just touched on why deep learning. So introduction to deep learning, right? So deep learning, fundamentally, philosophically speaking, right, is the idea that machines will mimic human intelligence. If you go on Google, that's the definition that you actually see on Wikipedia. But fundamentally, it's actually a mathematical function. Each and every deep learning model is like a function, but composed of other functions. So if we do like if I am to explain it with high school mathematics, a deep learning model is just like a function f of x, but in that function it's actually made up of different smaller functions, right? And then the way in which these functions are connected is determined by the data, right? So a deep learning model is made up of a dense layer of what are known as neural networks, right? This is where the magic happens. These enable the machine to actually learn. Next slide, please. Yes. So if let's just go back to high school for those audiences that are you've forgotten the prerequisites of high school, but I'm just kidding. In high school, we know that a function f of x can be a composite function. It can be made up of infinite function inside it, right? Same thing kind of applies with the deep learning model. But what we are doing with the deep learning algorithm is that we take the data as the domain, and then we map it randomly to a certain label, right? So your domain will be your data, and then the range of that domain would be the label, right? If, let's say, if we want to classify a cat from a dog, your data will be pictures of cat, and then your range, right, will be the label, specific label saying that this is a cat. Now, the composite functions inside the model, these can be pictured as small neural networks. The positioning and assigning of the constants, right, in that function can be determined by the amount of data that you'll be feeding to your model. So it's practically trial and error. Deep learning, what it tries to do, right? If you can look closely at the slides, this is a more complicated view of the deep learning algorithm. That was just using basic math, but now you actually have your what are known as activation functions, and then your model, it learns first time, which is known as forward propagation, and then if it fails, then it also does what is known as back propagation, and then it assigns constants to what are known as weights and biases. So these constants can vary depending on the data and the amount of data fed into your neural network. So the denser and larger your neural network becomes, and the larger the uh, input nodes, right, or your parameters, the faster and more accurate your algorithm becomes, right? So this is why deep learning is so powerful. And basically it can all be simplified to what is known as a perceptron. A perceptron is a single, we picture a single neuron and its input variables and its activation functions. So, like I said, my example, my analogy was that we use it's like a composite function. So basically, a perceptron is the single function that composes the main function or equation, right? So basically, we input data into the into the perceptron, right? The neuron, and then they are what, if you can look closely on the slide, there is W1, W2, W3, and WM, right? These are called weights and biases. So initially they're just set as random. It's just a random variable because we do not know the what the data is, and then we map it to a certain label, right? All the features of let's say we are trying to classify sound, right? All the wave fronts of a sound wave are transformed into a vector, which into a number, and basically it is mapped into the it actually adds all the individual parts, and then an activation function flips that number into a probability, and then it is then mapped to another function y, and if your neural network is larger, it is then fed to the whole model. You can picture it as sort of like we are trying to let's say it's a school, right? And then when you enter a school, there's a guard, there's security at the gate, right? And then the security, he says, what is your name? He asks you some information, and then he goes the information to the headmaster's office or whatever, to the reception, and they said, oh, okay, we are expecting this guest, right? So that saying that we're expecting this guest is like a label, right? And then the guard then identifies, saying, oh, okay, this is an important guest, and then it is sort of memorized within the equation thanks to those constants, weights, and biases in the terms. Um, this is very basic. This is like very overly conceptualized stuff. So I recommend I will send a link into the chat on MIT's lecture on deep learning that I took so that I can sort of like understand what is actually going on. Now, when you take a single perceptron, right, and then you connect it to others, this is when it becomes a multi layer perceptron, right? And then it gives different outputs, which will be in form of y, which will be a function, right? So all they all are connected, and each neuron is dealing with a single feature. Let's say teach you're trying to create a software that does accounting, right? So we can picture each and every neuron tackling, okay, saying that, okay, this is an expense, okay, this is maybe, I'm not an accounting guy, but you try to, this is turnover, and this is a certain part, and then this is the accounting equation, and each neuron sort of like deals with that part, and then feeds it to the next neuron, which goes deeper and deeper and deeper and deeper, up until you get to saying, okay, this is just a value of $1, this is just 1 cent, right? And then it tries to now predict and understand what is actually going on in terms of accounting, right? And then it gives you a sample saying, okay, this, I think, doing your profit may be $360, your expenditure, etc., right? So basically, that's the foundation of how neural networks work. So how deep learning actually works. But now they are what we call deep learning algorithms, right? And these are critical in terms of which problem are you going to solve, right? There is what we call supervised learning and unsupervised learning. Supervised learning, this is when we explicitly put the labels on our, let's say, on our data set, right? We map it to a certain label. But then when it comes to unsupervised learning, right, we just want the neural network to understand that this an object A, if it is a convolutional neural network, is different from object B, right? It does not necessarily have to know that this is a cat and or this is a dog, right? But then the idea is sort of like to train the algorithm to understand without putting any labels that, okay, this feature is different from this feature from essence, right? So these will differ from a problem that you are trying to solve. If your problem is a lot of spatial data, you do not need to use a temporal algorithm that involves time, or a sequential algorithm. For instance, let's say if you want to classify an image, you do not there is no time involved. So selecting an algorithm is actually one of critical steps in solving a certain problem. Now, um, the the algorithm, they differ depending on the neural networks inside the model. If it is something that involves temporal data, that is sequential data, which involves time, the the inputs on the function will be actually looped around the network, because we are reusing the information from this neuron, and then it can be used again back backwards, and that sort of like creates a sequential system. So there are plenty of algorithms out there that you can try out. I've on my project for flood prediction, I've actually fallen in love with the current neural networks and degenerative models. I'm trying to join the two, because degenerative model, they sort of like they learn the probability distribution, right? And then they try to recreate the outcomes. And recurrent neural networks, they're actually good with sequences, right? If I'm going to say amen, right, they will model the the individual parts of my voices. So for a problem such as flood prediction, right, I'm trying to actually saying, okay, with past data, can is it possible to teach my model how rain is going to actually form, how the temperature is going to change, right? And deep learning is powerful because not every problem in data science is solved by regression, right? There are complex functions in which they can create patterns, and these have to be addressed with deep learning. But since these algorithms are hungry for data, right? In order for our algorithm to be fair, and let's say maybe you are doing an algorithm that sees if a person is able to pay a loan, there are ethics around those issues, right? Because your algorithm has to be fair. This is when the importance of addressing data bias comes into action. Um, so, what is data bias? So, basically, data bias may result in terms of domain shift. Um, like I will relate to Mr. Lovemore, who was talking about agriculture, and he said that their algorithms were tested in Zimbabwe and I think in some other parts of SADC, right? But what if we want to test that algorithm in Ethiopia? It's a novel algorithm, but then in Ethiopia, the climate might be very, very different from, the southern region, right? This is when data bias has to be addressed, and it may be due to what is known as domain shift. Like I said, the domain is the data, right? And you have very, very little data in your training set. If you look at the slides, you can actually see um, how how you can confuse some computer vision models, right? You can see this dog is lying on the table. It looks like it's lying, and then this other part is looks like it's standing up, and this other part is look like it looks like it is sitting, right? You can actually see that this when it comes to a real world problem now, you have to be super super careful because imagine if it was $1 million algorithm that was trying to detect a dog, and then boom, it fails, right? And for an enterprise like I did some BS back in the day. You're trying to make a good or a product that is, that will be acceptable by your users, right? You don't want to disappoint. So whether you are in a firm or you are in the scientific realm, data bias is something that is important, whether it's even machine learning or reinforced or deep learning, right? These are super, super, super important, right? So yeah, my slides there were, like I said, I'm still a high school student, so I was taking a physics test, I think yesterday, yeah, the day before yesterday. So my slides were not finished, but let me just jump into how to get started with deep learning. So this meme is something that can relate to almost everybody in Zimbabwe, right? That you have a major project and your laptop is like a bicycle and you're trying to sort of like pull an aeroplane using a bicycle, right? Luckily, there are now cloud services that you can use. I think Miss Henrika mentioned it on Monday, was it Tuesday, right? Some of the major web services that you can use. But for me, I use for most of my projects, I use Google Colab, and it at first it's intimidating. Like you have these algorithms and you're watching these YouTube tutorials, right? And you do not know where to begin. But these are just buzzwords. Artificial intelligence is not that hard. If you come from a mathematics background, a mathematics, economics background, physics background, then you already have the brain power. It's just because it's just a deep learning, right? And it sounds like it's something that is very, very, very hard to do. If you have that mathematical background, you can sort of like jump into it. And it's at start, it's like you're juggling a boulder, but then like as the meme on the left suggests, you get used to it, right? So but what I love about Google Colab, right, is that they give you a free GPU. This is a fast computer that is able to train machine learning algorithms faster, right? Um, so basically, Google Colab is just a developing environment where you'll be working on your cloud, is synced to your Google Drive. And the only catch is that when you're working with larger models, let's say maybe 30 gigabytes, you have to buy more storage. But that's about it. And it is integrated with some of the major tools, which are TensorFlow, Keras, and Keras is something is sort of like a module that you can create your deep neural networks from scratch. If you want to create a shorter neural network, maybe for classifying maybe a simple regression problem, right? You can use that. And the more you get comfortable with using Google Colab, you can even do reinforcement learning. There are YouTube videos and even tutorials where you can create a, a like the deep mind. So yeah, there's this company called Deep Mind, and it sort of like motivated me to actually join to to venture into AI. They solve some of the world's toughest problems in science, in geography, and all those other sectors, right? So you can even try they open source their things. And once you feel like, obviously this is for personal stuff, I think Amazon Web Services, those services that Miss Henrika mentioned, will be for a large company. But let's say that you're just like fellow Tinevimbo Musingadi, and then you just want to venture into deep learning. You can start with Google Colab. It's pretty comfortable, and plus it uses our old friend Python, right? Python is just an easy language. It's not complicated as compared to maybe C++, right? But if you are comfortable with JavaScript, also you can use Google Colab. It's rather unfortunate that I'm not able to do a demo on Google Colab. I just wanted to create maybe a short neural network on my Google Colab. But basically, TensorFlow, Google Colab is well integrated with TensorFlow. And Google's idea is try to promoting artificial intelligence to use deep learning essentially to be used um, for solving community-based problem. And it's really free. You can, yeah, there's this other hack that I use. If I am using a larger model, I actually create two accounts on Google, right? I know it's not ethical, but if you do not have the money to buy storage, you can actually create another account, and then you sort of like connect those two accounts. It's pretty fun. But then the, the most important part is that you are able to get not just watching MIT lectures, right? You're actually trying it yourself, going on Google Colab. There's no limitation. Limitation can only be maybe electricity and internet access. But once you have those, you can even do it on your smartphone. You just go onto the cloud. Maybe you've written some codes, then you just try to experiment with those algorithms, right? So that's just a slide of importing your files. You can import your files from your Google Drives, and you can even import your files from your local machine, right? Maybe if you have a local data set on your smartphone, you just import it. Maybe you're going to work and it's a maybe it's an hour, it's an hour drive. You're just chilling, playing some music whilst coding, right? So yeah, it's like it's a very powerful environment, because you are able to sort of like solve real world problems to get your hands dirty. And you can even experiment with small data sets. Maybe you're doing in agriculture, saying, okay, we used the convolutional neural network, but what if we use a combination of maybe Facebook profit, and then we try to predict pests? And yeah, that's the beauty of the age we are living in. And if I can do it, obviously everybody can do it. It's not that hard. It just takes time to be committed to solving these problems. So yeah, I think in terms of my slides, that's about it. And I hope to those listening who hadn't started, I know there are experts who are listening and they may think that, okay, this kid is misinterpreting some of the stuff. Like a machine, I'm still learning. um, but yeah, if you haven't started, deep learning is something that I think, in order for us to, as a community, to start solving real world problems, we really, really have to venture into. And yeah, since I was sort of like the only high school student doing the presentation, I think the community, those experts like Mr. Lovemore, you should find some students whom you should mentor, so that, because most people, there's this in Zimbabwe, like I'm currently a lower six student, right, in at Mavuk High School, and there's this peer pressure about saying maths, physics, chemistry. These are the only fields that the geniuses do. the top ranked students at O level. You see someone, yes, 12 A's in computer, he had an A in computer science, then he goes in chemistry, physics. But then these fields of computer science, statistics, and deep learning, these are the let's say the pillars of the fourth industrial revolution, right? So my words to all the other people listening: if you are in data science, just grab a mentor, whether just grab a mentee, a student whom you want to teach this stuff. And yeah, this will enable us to, because at the end of the day, it's about solving these economic problems, especially the economic problems that we are having in our societies, right? Imagine if I was actually like interested in agriculture. I think I will also do a research in agriculture. Imagine if we are able to maybe fast track the production rate, right? Production, demand, and supply that would affect our economy positively. So yeah, that was from me, Tinevimbo. Unfortunately, I do not have a lot of things to say now. So if there are any questions, I'm able to answer them. Thank you very much.
Wow. Such inspiring stuff from you, young man. I'm sure a lot of the people who are listening and in their networks as well will take some of your suggestions with regards to helping out other high school students so
Mentoring.
that we start a lot earlier. I think this would be a good platform to say if if we would really love to work with you at Data Science Zimbabwe as an ambassador, reaching out to a lot of your colleagues in schools and showing them what is possible. That you do not really need to have a PhD in order to just start
Yeah.
playing around with some of these tools. Yeah. So and I hope some of the people who, as you have said, who are more experienced in our community, will also take it upon themselves to help with ensuring that people in high school understand this particular field and get guidance into starting with it. So we will probably have more discussions after this. We've got an NVIDIA Jetson Nano, which we think would be very much useful in some of the projects that you're doing, and would love
Okay.
to have you use that to build some of your projects, and then you
Mm-hmm.
can showcase what you would have built on the Data Science Zimbabwe platforms, as well as in your ambassadorial work as you are helping other students, other young high school students to appreciate what artificial intelligence, machine learning, data science could mean for Zimbabwe and Africa. So, if there are any questions or any words of encouragement, would love to see them in the chat. Um, okay, we've got quite a few. Let's see, Zimbabwe's talent. Certainly, you are representing the talent that Zimbabwe has. We definitely need to harness that passion from a very young age.
Okay.
Tino is a super talent. Certainly, that's very true. Yeah, I can't believe this is
Um,
a high school student. Great insights and articulation, Tinevimbo. That's amazing stuff. Thank you, Nananai. Very inspiring, great insight, young man. Well done, Tinevimbo. What a mature presentation. Even the sky will not limit you. We'll get in touch through Love Mochi Pindu. Well, that's amazing. That's amazing stuff. All right. Tinevimbo is also on LinkedIn. And if you want to engage with him further, you could take him on LinkedIn, and we'll also share the links that he has mentioned in his presentation to the MIT, is it? MIT lectures.
yeah, it's MIT six
Okay,
one. Okay, I'll just share I will
the link.
share the link to you, and then you forward them
Then,
to the
okay,
community.
cool. Certainly.
Yeah, I would just like to say a few words.
Yeah.
Thank you guys for the motivation. Um, this is what keeps me going. Saying that okay, I now have a community that is picking up right here in Zimbabwe, right? And yeah, I'll keep as an ambassador. I'll try to find other folks out there who are interested in deep learning. It's rather too bad. I had a lot to speak, but due to technical issues, Zimbabwe and stuff. But yeah, but that's that is what we are trying to do to solve problems. Maybe who knows? Maybe deep learning may come up with a faster way of maybe producing electricity. We never know. We never know because it's so much. It's so much. It's like the next electric motor. When the electric motor was invented, it started to be used in um, Chigayo, like Emilio Mills, Millers, smartphones. Now it's being used in electric cars. So this is like the fourth electric motor, and I am very very much honored to be on this platform. Um, Thank you very much, Data Science Zimbabwe, for giving me this platform to share my work, and I'm forever inspired by you. And I will make sure that I will find other students who are willing to be a part of the community as well. Thank you very much.
All right. Thank you very much, Tinevimbo. So we will break for about 10 to 15 minutes as we get the next presentation online. And then we will continue with our sessions today. I think the next session will be mainly on machine learning, specifically the hackathon that we are running together with Zindi and Replitech AI on predicting fire, predicting the area that is burnt by fire in Zimbabwe that we could harness for multiple use cases, for example, food security, yeah, ecology, and environmental preservation and the likes. So looking forward to seeing you all in the next session. Thank you.